Good day, everyone. Our topic for today is all about problem solving involving quadratic inequalities. Now that you have learned how to solve quadratic inequalities, you may now apply what have you learned in solving word problems. Since word problems require analysis to get a working inequality, always check for phrases that translate the inequalities. Aside from the traditional way of reading the symbols, this one, less than, greater than or equal, or less than or equal, here are the some phrases to look out for. This symbol can be read as more than, greater than, or go beyond. This one can be read as at least, no less than, at minimum. This one is less than, smaller than, should not reach. And for this one, that is at most, no more than, at maximum, maximum, should not exceed. Be reminded that when you solve quadratic inequalities, it is same with quadratic equation. Just turn the symbol into equal sign. Then find the critical values by setting test points in each interval. You have tried also solving problems. We may use these steps in it. Identify the given and what is asked. Draw it when make representation for you can write the correct inequality you needed. Let's try some problems. Problem 1. The product of two integers are at most 33 and their sum are 14. So what are the two integers? So we're looking for the two integers wherein their product is at most 33 and their sum is equal to 14. So step 1, read and analyze carefully the problem. List down the given facts and what is asked in the problem. So given facts, the product at most 33 and sum is equal to 14. What is asked? What are the two integers? So the problem, the product are at most 33. So from the word at most, this should be the highest number. Then there are some numbers that are lower than this 33. Okay, 33 is the highest number. It can be equal to 33, but it can be less than 33. And then the sum is 14. Is equal to 14. Okay. Now, step 2, make representation. So let x be the first integer. And let 14 minus x be the second integer because let x, our first integer might be x, okay? And the second integer might be 14 minus x because their sum is 14. And if you subtract x to 14, you will get the second integer, right? So to set up the working inequality, the product of the two integers x and 14 minus x is at most or less than or equal to 33. To solve this one, we will uh, we will multiply x times 14, that's 14x, and x times x is negative x squared, and then transpose 33 and becomes negative 33 less than or equal to 0. And then rearrange this into as decreasing order by exponent. So we have negative x squared plus 14x minus 33 less than or equal to 0. So look at the quadratic inequality, x squared is negative. So we need to remove the negative sign by multiplying negative 1. So it becomes x squared minus 14x plus 33 um, as compare here, okay? So it becomes this one. And since we multiply, okay, we multiply them by negative 1, we will change now what they call this, the symbol here, okay? Remember that when you multiply or when you do something with the equation, we always change the inequality sign or symbol. So from less than to or equal, magiging greater than or equal siya. And then from these, we can find out the critical values by solving the roots of the equation. So what will be the factors for x squared minus 14, x plus 33? So think a number that, what are the factors of 33? And that is 11 and 3. The sign is negative, so they are both negative because anything that you multiply to negative, or if you multiply both negative, you will get a positive answer. So x times x is x squared, negative 3 times negative 11 is positive 33, and negative 3 plus negative 11 is negative 14x. So we have these two roots. So we have x equals 3 and x equals 11. Okay, now let's check. Using inequality, okay, we have this one. The our interval, okay, by the way, our symbol is greater than or equal to 0. So if it is greater than or equal to 0, it's greater than, so our symbol here should be shaded. Now we will shade this because it is greater than or equal, so it should be there. Now, x is greater than or equal to 11. That's our assumption because we have two numbers, 3 and 11. If you still remember our quadratic inequalities discussion. So we have um, x is less than 3. So it can be, I think this one can be infinity and 3. Okay. And then for this one, we have 3 and 11. And finally, for 11, we have 11 to infinity. So I think this one is negative, negative infinity, because this one is positive infinity. All right. Now, for the negative infinity and 3, what are the numbers that you can think greater, less than 3? And that is 2. So we can use 2. Okay. So we will just substitute 2 to both our equations, so to determine if our answer is correct. So there's something wrong with the with this one. So we have 2 minus 3 and 2 minus 11, so that's negative 1, negative 9. The answer is 10. 10 should be less than or equal. Okay. So we change pala the the what they call the symbol. So it's greater than or equal to 0. Is that correct? Okay, that's correct. For this one, what numbers can you think between 3 to 11? And that is 5. We can choose any number between these. We can choose 4, 5, 6, 7, 8, 9, 10. So we have x minus 3 and x minus 11 greater than or equal to 0. We just substitute x, 5 minus 3 and 5 minus 11. So that's 2 times negative 6, that's negative 12, greater than or equal to 0. Is that correct? No, because it's less than 0, so that's false. And for this, x is to infinity, 11 to infinity. So what numbers can you think? Greater than 11, that's 12. So just substitute 12 to the equation that we have, and the answer is 9, greater than or equal to 0. That's true. So therefore, our solution set here will be negative a infinity 3, okay, union of, since it is greater than or equal, right? Greater than or equal. So there is this one symbol, and that is 11 and positive infinity. So these are the solution sets, okay, for this particular example. All right? Or simply x is less than or greater than or equal to 3 but less than or equal to 11. Okay? So this is our solution set. To verify the answer, there are numerous pairs of numbers that can be made to satisfy the problem. For such, you can have the following numbers: 3 and 11, 2 and 12, 1 and 3, 13, 0 and 14, negative 1 and 5, 15, etc. So if x is the first integer, 14 minus x is the second integer. If x is equal to 3, then 14 minus 3 is equal to 11. The two integers are 3 and 11. So if you multiply 3 times 11, that answer is 33. So that's correct. If we will choose x equals 2, x is equal to 2, and 14 minus 2 is 12, okay, the two integers will be 2 and 12. If we will multiply 2 and 12, that is 24, and it is less than or equal to 33. Is still correct. Okay, so we can choose any numbers wherein our x might be less than 3 or greater than um, greater than 11. Okay, greater than 11. So okay, so that's all about for the uh, problem solving involving quadratic inequalities. With that, thank you very much for listening.